Good evening and welcome to this night's edition of Kinematic Equations with Mr. Bell, part of his Physics 1 pre-AP curriculum. Today's objectives is that by the end of the video you should be able to recognize all of the kinematic equations and you should be able to solve problems involving displacement, velocity, time, and constant acceleration. Again, just to review some of the symbols that we will use, T will be for time, D or X is for displacement, V will be used for velocity, A for acceleration, delta symbol will be for change, and now we are going to introduce two new concepts. Instead of calling things V1 and V2 like we did earlier in class, we will call things not, which means it has a little zero at the bottom, or XF for final. So if I were to read this, I would say X naught, and that means the initial displacement. So instead of using 1 and 2, you will often see naught and an F for the initial and final results. So from the kinematic equations, last time we had these two that we worked on, okay? And technically, the kinematic equations are these three, the next ones. This is the first one, but if you look really close at it, you will notice that the V final and V initial, if you put them together, is just delta V. And so essentially, it is the same thing as the other equation that we used today, is that average acceleration, V final and V initial. This over here is the exact same thing as this. Yep. So the new equation that we're now adding is that displacement equals the initial velocity, or V naught, times time, plus 1/2 the acceleration times time squared. And then the next equation, so really we're only introducing two more equations tonight, is that the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the change in displacement. Okay, and this last one is your friend, and it's one of those that, like, you will notice that all of these contain time, right? And if they don't give you time in equation, you are probably going to be using this last one, because this last one is the only kinematic equation that does not require that you know the time, the exact time that something happened. So again, just to review, we're going to use Geoffroy, right? We're going to always show givens, formula, work, and answer. So here's our first example, okay? I'm a Hurrian is approaching a stoplight moving with a velocity of 30 meters per second. The light turns yellow and Ima slams on the brakes and skids to a stop. If Ima's acceleration is -8 meters per second squared, then determine the displacement of the car during the skidding process. Okay? So when I come across equations like this, often even before I do my givens, a picture is really, really helpful. So here's my picture. She is approaching the red light at 30 meters per second. And it says she skids to a stop. So now she doesn't have velocity anymore. Okay? Which means I know acceleration went against her motion and is a negative, right? And then I'm supposed to calculate her displacement. So for my givens, I want to find displacement. I know acceleration, and I know the initial velocity, or her V naught, as 30 meters per second. Okay? Do I know V final? That's a question you should ask yourself, because I'm all alone and nobody actually is here to ask. But yes, you do, because if you notice, she skidded to a stop. That means her final velocity is, in fact, 0 meters per second. So now we're going to look for an equation that contains distance, acceleration, and velocity, no time. And remember, like I said, there's only one equation that has no time, and that's this one. So I need to solve this equation, so that's my formula, right? So GF, now we're into W. When I solve for work, I need to solve this algebraically for D alone, okay? Since I'm changing a distance and or a displacement, I'm going to kind of drop the delta sign, okay? And so I know that displacement, when I solve for it and it's all said and done, is going to be the final velocity squared minus the initial velocity, because I moved this guy over here, and then finally divided by the 2a, okay? So once I have that algebraically solved, now I can plug in some values, and so I get 0 for V final minus 30 meters per second, quantity, everything is squared, divided by 2 times -8, okay? Don't forget that it is v naught squared, so you are squaring the 30. So 30 squared divided by 2 times 8. And that gives you a displacement of 56.3 meters to the right, because obviously if I have a negative acceleration this way, I have defined this way as positive. So displacement from here to here is positive 56.3 meters to the right. Okay, our last example. Ben Rushing is waiting at a stoplight. When it finally turns green, Ben accelerated from rest at a rate of 6 meters per second squared for a time of 4.1 seconds. Determine the displacement of Ben's car during this time period. So again, I'm going to start out with the picture just so I understand what's going on. He's starting from rest. Rest is just another way we say that he's not moving, right? Like when you're resting on a couch, you are not moving. So he starts at a rest, and then he accelerates at a rate of 6 meters per second squared, which means after that he's going to be going some speed, right? And I know that he has an acceleration. And I'm supposed to determine the displacement, and so I know I'm looking for a distance between the two places, okay? So unlike the last one, now they did not give me any velocity, right? But they did give me time. So I want displacement. They gave me his acceleration. They gave me his time, right? And that's it. Are you sure? Do I know anything else about the situation? Because none of my equations have just d, a, and t when I look at them. They have to have something, okay? And you'll notice that one of them needs v initial. Do I know the initial velocity in this problem? And the answer is yes. It said he accelerated from rest. So that means the initial velocity is 0 meters per second. So they did tell you that, even though it's not a number in your problem. It's a little sneaky. So now I need an equation that has dAt and v naught, which I find right here. Okay, so it is already solved for displacement, so yay, no algebra. I plug in all my values, 0 for v naught, 4.1 seconds for time, 6 meters for acceleration, and then 4.1 seconds for time again. Okay, since over here 0 times 4.1 seconds is 0, that's really, not affecting this at all. So I just cross it out and move on, and I get 50.4 meters to the right. And that is example number 2. So again, those are all the kinematic equations. When you come into class on Wednesday and Thursday, we will be going over homework questions, and then you'll have me to help you with them, and it's going to be great. We're going to get a lot of practice done. Good night.